Hello, everybody. My name is Masood Olia, and I'm a faculty in the School of Engineering at Wentworth Institute of Technology. And I'm back today. I just made one video, and I'm back again with another video since this happens to be the end of the semester, so I have a little bit more time to show you more examples. This time, the subject of statics, topic of truss, method of sections. We want to talk about method of sections here, and I have more examples on method of sections in my channel. But here, in this particular problem, this is really a basic problem. We are trying to find the internal force GE, so the forcing member GE, the forcing member GC, and the forcing member BC. That's the objective here. So basically, this member, as you could see, and this member. So you see, this problem already shows you the picture members that are we are interested to figure out the internal forces in them. So you see the cut is going to be cut as shown here. So just like that, we cut it. And then we look at what internal forces are developed at these different members. So those internal forces are important. Those members are either in tension or compression. Okay, so let me show you in this particular problem. So this is a simple, really, truss. We do have, regardless of which side of a truss we pick, either the left side or the right side, we need to know what's going on at A and what's going on at the roller D. So we have a pin at A or a roller. You could select which side you want to pick, eventually the side that is more efficient to use. But first, we need to find the reactions at the pin, which is going to be AX and AY, and the roller reaction, which I'm going to call it DY, right? Roller, just one reaction, pin, two reactions. Rigid body equilibrium that you could easily take moment about. That since if you balance the forces in the X direction, sum of the forces in X equals 0, right? What do we get? AX has to change direction and be equal to this 400, right? Because this 400 has to balance actually the direction of what? To the left, basic equation, just equilibrium in the X direction. In the Y direction, though, we need to take, in order to find dy or ay, we A or D. Let me take a moment about A. What do we have? Excuse me. About A, so that's dy times 12, right? That distance. Going positive, because I pick counterclockwise to be positive. And then I have two forces, moment of 400 going negative, 400 times what? Times 3. And then moment of this 1200 times 8 also going negative. So we have 9600 and 1200. That's I have actually the picture here. So dy should be, let me just do a quick calculation, guys. I will calculate time. We have 1200 and 900. We add them, we divide it by 12. So that's 900 even. So it becomes 900. So if dy is 900 and you have 1200 going down, so what should be ay? So just balancing the forces, ay should be 300. So 300 plus 9. So just balancing the forces in the y direction, AY becomes 300, and the direction of it is right. All right, so now you have to decide after you cut this like that. The method of section is that when you cut, you shouldn't, in general, you shouldn't cut more than 3 members. It is possible to cut more than 3 members if the geometry allows you, because you don't want to have more than 3 unknowns. That's the rule. So you decide which side you want to pick. If you pick the internal forces like this, if you pick the right side, the same internal forces that you see here, right? So well, really doesn't matter, because you have one load here, one load here, one. But if actually you have just 2 loads, so left side is more efficient, and the free body diagram of side is shown right here. You see that, like that. Actually, I don't want to show you that picture. And so it's AY, which is 300, and then when you cut, the easiest way to figure out these forces, these internal forces, to show them that they're in tension. So FGE in tension, because if you show it, they're pointing away from the member. FGC also in tension. Then solve the problem. You see, we only have 3 unknowns. Solve the problem applying equation can be used. The basic 3 equation: take moment about the point, balance force in the x and in the y. But the whole idea of this possible, okay? If you show these forces, assume they are in tension, so they're pointing away from the joints, right? This is A. Then if you get positive, they're in tension. If you get negative, they're in compression, right? So for example, if we go ahead and take moment about G, you see, that's a good point to take moment about G and GC don't have any moment. So we can find the moment of, don't. Right. So let's go ahead and do that. Let's take counterclockwise to be positive. So moment of FBC about G is FB3, right? That's going positive. This guy, which would be in the negative direction, 300 times, looks like 4, that this divided by 3 FBC happens positive 800 Newton, and direction of FBC is good, and so that member would be in tension. All right. So now, what would be a good point to take moment about so that you could find example FGE? See, these 2 guys, they intersect at C. See that? At point C. Take moment about C. If you go ahead and take moment about C and equal to 0, then these 2 forces eliminate member FGE. So let's go ahead and see. That's FGE times 3. That is going negative clockwise. 100 times 8, that distance. And 400 actually is lined up. You see that? 400 is lined up with. But easily see that F has to be negative. The way we would write our answer is that FGE is 800 Newton and uppercase C, which means that member is in compression. What's the significance of members being in tension or compression? Compression in danger of being buckled. So you want to actually reinforce those members. So buckling is a mode of failure trusses. So you have to watch out for those. So that's why we have to know if a member is in tension or compression. All right, and then finally, see, we don't have the luxury of taking a moment about the point, but because you see, remember that we haven't figured out its value, the force, the internal force is GC. We could go ahead and use some of the forces in make any difference. If you do some of the forces in y equals 0, which is more efficient to use, what do we have? We have, you see this guy is going down in the negative direction. What is its component? It has a slope of 3 or 4. So y component would be 3/5 of also in tension. So here we go. So you see actually the correct directions here. You see BC is in tension and is 800. GC we just determined is 500. You see the direction is the same. And this guy has to switch direction, this one, and be what 800 in compression. All right, so I hope I was able to show you this problem and you learned something from this video. As always, I appreciate if you could, subscribe to my channel and like the video. Thank you, and I will see you soon.